Hello, pre-calculus honor students. Here we are with a review of integral and rational exponents. Let's first see where these are used in the real world. Suppose that the dry erase marker costs $18.95 and it increases at a rate of 9% per year. What will it cost in 2012, just 1 year from now? Well, we'll multiply it by itself, 1, plus 9% of itself, or more simply put, multiply it by 1.09. And the new price of the marker next year will be $20.66. Now in 2112, now we'll take that $18.95 and keep multiplying by 1.09. The difference in years there from 2112 back to 2111 is 101. And if this keeps up, then the marker will cost $114,000. That's exponential growth for you. And 10 cents. Now, what did it cost back in 1985? Well, you take the price and now take the 1.09, but raise it to the negative 27 powers to represent the fact that this was 27 years ago when I first started teaching here at USM. And the markers were only $1.85. Now, recall these rules of exponents involving the same base. Products of exponentials with the same base, you add their powers. If you divide exponentials with the same base, you subtract their powers. And if b to the x equals b to the y, then x equals y, vice versa. Now when you have the same exponents, you can distribute the exponent idea over multiplication or division. You can also say a to the x equals b to the x, then a equals b, as long as a and b are both positive. This won't work for something like x squared equals y squared, because you don't know if x and y are positive or negative. There's power of power and rational powers. Any radical can be written as a fractional power. The square root of x is x to the 1/2. The cube root of x to the 1/3. Here's our next example. Simplifying this, these go pretty straightforward. We can use the -1 power to flip the fraction. A over b squared, b over a squared, cubed. And then distribute the powers over this to get all positive powers. A squared over b to the 4th times b cubed over a to the 6th. Notice a squared cubed is a to the 6th. So you end up with 4 a's on the bottom and 1 b on the bottom. 1 over a to the 4th b. Example, simplify a to the -2 plus b to the -2, all raised to the -1. Students will sometimes tell me right away this is a squared plus b squared. That is just so wrong. You cannot distribute powers over addition. So we're left with, writing this as 1 over a squared plus 1 over b squared, all raised to the -1, which is 1 all over 1 over a squared plus 1 over b squared. And now we use the LCD idea. The overall LCD of both numerator and denominator is a squared b squared. We use this to get rid of fractions within fractions. So I multiply top and bottom by a squared b squared over a squared b squared. And you end up with then a squared b squared all over. Distributing this now, the a squareds cancel, you get b squared plus a squared. There's your simplified version. Okay, moving on with the review examples here. This one on the left is much easier because we can basically think of this as x to the 3rd, adding up the powers here, over x cubed, x to the -3, and then subtract the powers. X to the 3rd minus -3 is x to the 6th. On the other hand, though, x to the 5th plus x to the -2 or x to the -3, we can distribute this division by x to the -3rd over the addition. So it's x to the 5th over x to the -3 plus x to the -2 over x to the -3. and we get x to the 8th plus x to the negative 2 minus minus 3. So that's x to the 8th plus x. Very different kind of answer. Now, simplify some of these rational powers. Well, 16 you should know is 2 to the 4th, but if you don't see that, you could also look at this as the 4th root of 16, which is 2. Now, if you didn't see that the 4th root of 16 is 2, you can start breaking down 16 like into 2 to the 4th. 2 to the 4th all raised to the negative a 4th. So that's 2 to the 4 times negative a 4th. 2 to the negative 1 is 1 half. 8 to the 2/3. 8 is 2 cubed, so 2 cubed to the 2/3 is 2 squared, which is 4. Similarly, 8 to the negative 2/3 will be our other answer. This is 8 to the 2/3 raised to the negative 1, so we can take the answer from up here. So say 4 to the negative 1, or 1/4. Okay. Now let's try some solving problems. 2 to the x equals 1/8. Well, we can use the idea that if b to the x equals b to the y, then x equals y. And so this is solving for an unknown power even before we review logarithms, only because we can write both sides as a power of the same base. 8 is 2 cubed, so 1 over 2 cubed is 2 to the negative 3, ergo x equals negative 3. 9 to the x plus 1 equals square root of 27. They both seem to have 3 in common. So 3 squared to the x plus 1 equals the square root of 3 cubed. So this is 3 to the 2 times x plus 1 equals 3 to the 3 halves power. So 2 times x plus 1 equals 3 halves. So we have 2x plus 2 equals 3 halves. Subtracting a 2, 2x equals negative a half, so x equals negative 1/4. Now our last kind of problems then. 4 to the x, 4 times x to the 3 halves equals 32. Let's isolate the exponential expression, say x to the 3 halves equals 8, and then just raise both sides to the 2/3 power. As we saw before, 8 to the 2/3 simplifies into 2 cubed to the 2/3, or 2 squared, which is 4. Now here we can isolate the x to the minus of 4, x minus 1 to the minus of 4th. Don't distribute this negative 4th power over the subtraction. So x minus 1 to the negative of 4th equals 2. And now we take both sides and raise them to the reciprocal power. So we can raise both sides to the negative 4 power. So that we get x minus 1 equals 2 to the negative 4, which is 1 over 2 to the positive 4, or x equals 1 plus a 16th, which is 17/16. All right, flange out.